Well, hello. Today we're going to talk about piecewise functions, and it's just called a piecewise function because, well, the graph is broken into pieces, and each of these pieces can be defined with a separate equation. Notice this is still a function because it still passes the vertical line test. Even in this spot here where things appear to overlap, they actually don't because there's an open circle up here and a closed circle below, and when you see that open circle, that would be like a hole in the graph, so you don't really land on it, but the closed circle, of course, is a point on the graph that you land on. So look, we're going to start with just like questions that can be asked about this piecewise function, and then we'll write an equation for it and do a couple other fun things. Domain and range, of course, are always very important. So this is broken into pieces, of course, but for domain, we can, I'm going to use interval notation, by the way. For domain, you just want to go from the left to the right, and what you're looking for is where does the graph start, which this is going to be an x, like it's going over here, right? So it's going to start at an x of, well, negative infinity. And then it's trucking along and everything's all good and great. And then it stops here. But here's the deal. It doesn't really stop here because right above it, the graph continues to go over this interval. And even though it stops there, it picks up at the same exact x value and keeps going for forever. So because of that, my domain is actually going to be all real numbers, or negative infinity to positive infinity. Now, if there had been a true gap along the x-axis, I would definitely need to handle that. Okay, so let's look at range, though. For range, we're going to go from the bottom to the top, right? And so the lowest y value is definitely 0. And if we notice on this side, it's going to go up, for forever. And so basically every y value greater than 0 is going to get covered or counted based on this thing that's in green. I don't even have to look over here, honestly. I mean, you could if you wanted to, but you don't have to because this piece covers up everything. So there's no gap in the graph when it comes to y values, but it does start at 0. Notice where it starts is a solid line, so solid mean is like a solid point, and so 0 to infinity, and of course infinity always gets parentheses. Okay, so there's our domain and range. Now what about increasing, decreasing, and constant? Well, you've already learned these, so this shouldn't be too terrible. Increasing is anywhere we're going, the graph is going up, the slope is positive. So those two look like the increasing bits. The decreasing looks like this green bit right here, and then the constant would be just a horizontal. So how do I write those? Well, very quickly, as a refresher, you always want to use parentheses on these. For increasing, we're going to use our x values on all these to define where it starts and stops. So the x value where it starts increasing is 0, and it goes along until it hits 1, and then it stops because there's this gap here, right, where it's constant. Then it picks up again at an x value of 2 and continues to increase for forever. The U is just a math symbol for like union with. It's almost like the word and. So it's this and this. Those are the two intervals. Decreasing is the green. So once again, the x value that's on the far, far left is going to be negative infinity. And then it stops the decrease at 0. And then the constant interval, we're looking at our x's, right? So from 1 to 2. Okay, so that's how we would handle that. Now, where it gets tricky for a lot of students is having to write the equation for this. So, trying to erase quickly. When you write an equation for a piecewise function, you only need to have f of x written one time because this is still the same picture, right? It's still the same function. And then you typically see a bracket. Inside the bracket, you're going to have the different equations that go with the three pieces. I like to do these top to bottom as if it's going from the left to the right because we always read math like a book, left to right. So the first graph I see is this parabola, and we should all know that the equation for a parabola is x squared. Now I would look to see if that parabola has been shifted, but looking at it, it has not moved left, right, up, or down, and the first movement is over 1, up 1, which means there's no dilation. So this is the equation for this parabola, and what you're going to do is behind it, some people will do a comma, some will do a semicolon, and some will just do a gap, I probably do a comma more than anything else. But over behind it, what you're going to do here is put your domain restriction. Now, when you write your equation, guys, you don't need to write the words domain restriction, but this is where it's going to go. So what x values does this exist over? Well, it goes from negative infinity all the way until x is at 1. Now, notice what I'm going to do here. This is actually incorrect as it sits, because even though this piece exists from negative infinity to positive 1, see that filled in circle right there? That definitely means you need to say x is less than or equal to 1. So when x is in the middle of these two symbols, it's like saying x is between negative infinity and 1, and you need that line if it is a closed circle. All right, so let's go to the second equation. Well, the second equation is just this horizontal line. And the equation of a horizontal line is literally just y equals whatever that horizontal line is. So in this case, it's a 3. So y equals 3. And this happens anytime x is between 1 and 2. So it's like, are my symbols okay? Do I need to put a line under one of them? Yes, I do. This one over here. Okay. And then the third equation is also a line. Okay, so what I like to do is I kind of envision if this had kept going, what would it look like, right? So if this had kept going, the slope of this is 1, so the m is 1, and the y-intercept is 0, so the b is 0. So if you think about y equals mx plus b, it would be 1x plus 0. So this is just the parent function for linear as well, so I don't have any transformations. And this is going to exist, well, now I need to erase because I don't know where it existed. There we go. It's going to exist anywhere that x is greater than 2. So you could either just write x is greater than 2, or if you like the infinity thing, you can do it. Oh, that doesn't make sense. That's an x. Okay. 2 is less than x is less than infinity. So you can do it like that if you want as well. So that's how you write an equation. So what are some things or power you can do with graphs like this? A lot of times you're going to be asked to evaluate the situation, meaning a question like maybe, what is f of 3? What is f of 1? You know, stuff like this. What is f of 3/4? Something like that. So here's how you handle these. You have two options. If you have a graph, sometimes you can just look at the picture. So if it says f of 3, remember that's in the spot of x. So what we're asking is, what is the y value when x is 3? Well, the y value when x is 3 is easy to see that it's a 3. F of 1, what is the y value when x is 1? Well, that's a 1. Also easy to see. It is, I don't want y'all to think it's always the same number. I just happened to pick values where it was. So if I change that to a -1, f of -1, the y value when x is -1 is 1. So see, it can be, you know, different things. And then f of 3/4. Now, I am not going to use the graph because, y'all, look at this. If I go to x being 3/4 and then I go up, like, what the heck? Like, what is that y value? I don't know. It's at some funky fraction. So this is where the power of the equation comes in handy. What you want to do is you want to look at what x value you're up against, right? Like, in this case, it's 3/4. And you want to first find which of these 3/4 fits into. Like, which domain is it a part of? Is 3/4 between negative infinity and 1? Is it between 1 and 2 or 2 and infinity? Well, hopefully we all agree that it's between negative infinity and 1. And so what that means is this is the equation that you're going to plug 3/4 into. So it's like you're going to take 3/4 and then square it, because that's what that equation is. So that would be 9/16. So that's definitely a fraction we would not have figured out by eyeballing the graph. So that is the power of having these equations. One more and then I shut up. The last one is going to be, what if it gets a little fun with function notation, meaning, I like these. These are like more like puzzles to me. What if it's like 2f of -2 minus f of 2? Something like that. Okay. So if I want to do this problem, this really is like 2 times. Okay, so we need to find these values first, and then we'll do the math around it. So the first thing I'm going to do is, what is f of -2? Okay, well, f of -2, when I look at the graph, that is hitting at 4. So 2 times 4. Okay, then minus f of 2. What is the y when x is 2? So what is the y when x is 2? Please don't say 2, okay? It's actually 3, guys, because remember, this one's a closed circle, which means you land on it, and that's the open circle. So this becomes just an arithmetic problem. Final answer 5. So hopefully all that makes sense, and if you have any questions on piecewise functions, hit me up. But hopefully this was a decent review of some things from Algebra 2 and maybe a little bit of an extension from pre-calculus.